A more complicated example will include all three types of energies. So let's walk through this. What we have is a toy gun that is loaded with a little pebble of 20 grams. It's right here. And they tell us it's 20 grams. So remember, whenever it's grams, we need to divide it by 1,000 to get to kilograms. And what is done is this spring, this is the decompressed spring. And when it is loaded, it becomes shorter by 12 centimeters. So we compress, see how shorter it becomes. So this right here is 12 centimeters. So when the mechanism is engaged, and the little projectiles is coming out, at the moment when this is decompressed, what happened is, so we started with potential energy elastic. I assign this potential energy gravitational to be 0. So I don't care about where the floor is. I'm not trying to figure out what potential energy gravitational is at the moment when the gun is loaded. I'm just going to say potential energy is where it is going to be 0. At the very beginning, we only have potential energy elastic, which, remember, the formula is kx squared over 2, where we don't know what k is, but x is definitely 0.12 because we need to use it in meters. All right, so we would square 0.12 and divide by 2 and multiply by k, and that would be our potential elastic energy. That potential energy starts turning into kinetic energy and potential energy gravitational. Kinetic energy, because it's moving. Potential gravitational is because we're getting higher above the original level. At some point, which is right here, the spring is going to be completely decompressed, which means we are completely losing this potential energy. So elastic potential energy completely turned into both kinetic and potential gravitational at this point. It's higher, so it has gravitational, and it's moving, so it has kinetic. No more elastic energy. But then what keeps going on? Kinetic energy is going to now start turning into potential gravitational. The projectile reaches a maximum height of 20 meters. So this is our initial, and this is our final energy at the very, very end. Potential energy elastic, initial, is going to be potential energy gravitational, final. K x squared over 2 equals mgh final. We need k, so let's multiply everything by 2, divide by x squared. K is going to be 2 mgh final divided by x squared. So multiplied both sides by 2, then divided by x squared. That's going to be our k. All right, so now let's plug in the numbers. K is going to be 2 times 0.02 times 9.8 and times 20 for final height. And I'm dividing that by 0.12 squared. Plug in your calculator. Gets me 544 newtons per meter. That is the K of the spring. Now, what if I want to know the velocity of the projectile? Well, it's not quite at the maximum height. Well, it's still going up. So somewhere where my final includes both. Well, just for fun, let's make it halfway through. Not at 20 meters, but height of 10 meters. Remember that K equals, we calculate 544. 544 times 0.12 squared, because that's what they told us the original potential elastic energy consists of. Kx squared. We compress the spring to 12 centimeters. So this right here is kx squared over 2, and it will be equal to mgh, where h is now 10 meters, and mv squared over 2. That would be equal to, I will get kx squared over 2 to be 3.92. Or if I got mgh final from here, where it was 20 meters, that will also be 3.92. So 3.92 is the total original initial energy, and it turns into 0.02 times 10, so it's 0.2 times 9.8, that is 1.96. Half of the energy, if I'm at half the height, I only have half the energy left for kinetic. So 0.02 v final squared over 2. So you get 1.96 equals 0.02 v squared over 2, multiply everything by 2, divide by 0.2. So ultimately you are taking a root of, you might remember that that's a full square of 14 meters per second. So practice again. Give yourself a mass of the load in grams. Give yourself compression in centimeters. Give yourself the maximum height in meters. And then calculate K. And then get your H to be something different. Just make sure that it's less than maximum and figure out V final at that moment.